Good day and welcome back. Today we're going to talk about the force between two parallel current carrying conductors. At the end of this video, you should be able to derive and use the formula of the force between two wires. Today's topic will serve as a summary on what we have learned from 16.1 up to 16.4. So we have learned that when you have a current carrying conductor, there's a magnetic field produced around the wire. The direction of the field can be obtained by using the right-hand grip rule. When we put another blue wire at this point, so there's a magnetic field acted in the upward directions. So applying the Fleming left-hand rule, so we'll find out that there's a force acted on the blue wire by the yellow wire, which is to the left. So now at the same time, the blue wire also produces a magnetic field that the magnetic field acted on the yellow wire is in downward directions. So when you apply the Fleming left-hand rule, you will find out there's a force due to the blue wire that is acted to the right. So from here, we can see that these conditions fulfill the Newton's third law of motion, that for every action, there's a reaction force of equal magnitude, but in the opposite directions. So when we have two parallel wires that having the same directions of current flow, there's an attraction force occurs between the two wires. So now let us explore a two parallel wire having the different direction of current flow. So we are going to repeat the same steps. So the magnetic field acted on the blue wire will be in upward directions. And when you apply the Fleming left-hand rule, the force acted on the blue wire is to the right. And then you use the right-hand grip rule to identify the magnetic field acted on the yellow wire, which will be in upward directions. So the force acted on the yellow wire due to the blue wire is to the left. So here we can observe there is a repulsion force between two parallel wires having different directions of the current flow. So with this, we are going to derive the formula of the force between two current carrying conductors. So let us use two parallel wires having the same direction of current flow. First, let us denote for each of the variable in this case. The current flowing in both yellow and blue wire are I1 and I2. So I1 will produce a magnetic field B1 on the blue wire, which is in outward directions, while the blue wire will produce a magnetic field B2, which is downward directions. So the direction of the force on I2 due to I1 is to the left, while the force F2 acted on I1 due to I2 is to the right. So let us recall back what we have learned before. In 16.2, you are given with the formula of the force on moving charge is equal to QVB. And since current is the rate of flow of charge, so we have learned to derive the force on current carrying conductor in chapter 16.3, that the force is equal to ILB. And then we learn about the Ampere's law, which is used to derive the magnetic field strength. So the magnetic field strength due to a current is given as mu naught I divided by 2 pi d, where the d here is the radius of the magnetic field, which will be also the distance between the two wires in this case. So combining these two formulas, we can derive the force between two current carrying conductors, that in the end, we will obtain the force is equal to mu naught I1, I2 multiplied the length of the wire divided by the 2 pi d. So most of the time, we are interested with the force per unit length, and we can further derive it into mu naught I1, I2 divided by 2 pi d. So next, we're going to explore another more complex situations that we have three wires. I'm going to use equations from STPM 2019. From the figure, you are given with the current flowing in each of the wire and also the distance between the wire. So you are given with the resultant force per unit length on L is F. So first, let us derive the actual expression of the F. So basically, wire L will experience two forces from wire M and wire N. Based on the previous discussion, parallel wire having the same direction of current flow will experience an attraction force, while the wire with different direction of current flow will experience a repulsion force. So the wire L will be attracted to wire M, where the force will be a downward force. At the same time, it will also be pushed to the top by the wire N. So I will take the direction to the top as a positive value. So the force acted on L due to L will be a negative value since it will be a downward force. It is equal to mu naught I multiply I divided by 2 pi r, while the force on L due to wire N is equal to positive mu naught I multiply 4I divided by 2 pi 2r. So the distance between the wire L and N is 2r, so take note on this. And then we do the vector sum to obtain the resultant force per unit length. Simplify the equations. In the end, you will obtain that the F is equal to mu naught I squared divided by 2 pi r. So since it is a positive value, so the resultant force on L will be outward force. Next, we are going to derive for the force acted on M. So wire N will be attracted to wire L, which will be an outward force. And at the same time, it will be pushed away from wire N, which also to the top. So both the forces are in the same directions. So now we're going to derive the force acted by each of these wires. So the force on M due to wire L is equal to positive mu naught I multiply I divided by 2 pi r. While the force due to wire N is equal to mu naught I multiply 4I divided by 2 pi r. So simplify the equations. In the end, you will obtain 5 mu naught I squared divided by 2 pi r, which is 5 times of F, and it is an outward force since it is a positive value. So this kind of derivations questions require to observe the diagram and learn how to use the formula. So you also can derive the resultant force per unit length on N. And I will leave the answer here for you to check. It is equal to negative 6F, and it is a downward force. So that's all for my discussion today. If you have any problems to do the derivations, you can leave it in the comment section below. Also, do leave a like, share my video, and subscribe my channel. I will see you in my next video. Thank you.